Today we'll learn about probabilities in something called a binomial experiment. And from the prefix bi, you should be thinking about two. A binomial experiment is one that has two outcomes. Either one thing will happen or it won't happen, and we call that success or failure. So again, two outcomes. Success is one outcome, failure is another outcome. So we'll have to define for our experiment what we consider success. We talk about calculating the probabilities. Well, we're going to calculate the probabilities as part of an experiment. But when you have something that happens with a success or failure outcome, then the probability of that success, the underlying probability of success, is always little p, and that number won't change for the entire experiment. So p will be given to you, the probability of success, or it should be something that's obvious to you, like if I say the probability of having a baby girl, you'd say the probability of success is 0.5. That means failure is the complement of success. So p is success, failure is 1 minus p. And we have another name for p, we call it q. If you look at this, take p and add 1 plus p minus q, or 1 minus p, then that's the same as saying p plus q is equal to 1, and there's your idea of complements. Okay, here's a formula that you have to memorize. Now, the first part of the formula is just a combinations formula, which you can get out of your calculator, so you don't need to do anything more specific in there other than write down NCR and use your calculator button to calculate that. The next two things are P, your probability of success, and Q, your probability of failure. Remember, P plus Q will always add up to 1. And then we have exponents here. Your number R is the exponent on P, and N minus R will be the exponent on Q. Now you've already identified N and R because you've already written this combinations formula. So again, that's a formula that you want to memorize, and that will be the formula that allows us to calculate any of the probabilities in a binomial experiment. N will be your number of trials. Now, number of trials will be how many times you conducted the experiment, or that should be obvious from the problem, and it'll tell you, it will be obvious. R will be the number of successes that you're interested in. We'll see an example of this in just a minute. Probability of success is something that you'll have to know, or it'll be obvious from the problem. In this case, we'll call it 0.9. Q will be the probability of failure. So if we're talking about this particular problem here, if 0.9 is the probability of success, then the probability of failure has to be 0.10. Those two are complements of each other. They add to 1. So those are the basic variables that we're going to be looking at in a binomial experiment and calculating those probabilities. And again, that formula is one you want to memorize, so make sure you have it written down. Okay, here's an example. If a family contains 5 children, what is the probability that exactly 3 of them are boys? Well, we're going to begin by identifying our 4 inputs to this formula here. We are going to run an experiment. Our experiment is actually those 5 children. So in this case, n is equal to 5. We have to define what success is. Now we're asking about boys, so we'll say that success is having a boy in the family. So what is the probability of having a boy? Well, probability of having a boy is 1/2. That's the underlying probability. That's the number that you'll be given. In this case, you weren't given explicitly, but you were told that you're having boys, and it's a 50-50 proposition. If P is 1/2, P plus Q have to add up to 1. So Q will also be 1/2. 1/2 plus 1/2 is equal to 1. And now R is how many successes we're talking about. In this case, we're saying exactly 3 of these 5 family members are boys. So we're going to say that R is equal to 3. And once we have those 4 numbers identified, we can start plugging into our formula. So let's see what the formula looks like. We'll write NCR, so that's 5, choose 3. We're going to multiply by P, which is 1/2, and we're raising that to the R power. We're going to multiply by Q, which is also 1/2. We're going to raise that to the N minus R power, so 5 minus 3 right here is 2. And if you run that through your calculator, that'll allow you to calculate the exact probability of having 3 children, or the probability of having exactly 3 children in a family of 5. A second example, we're going to open 10 new restaurants. Now the probability of success for a new restaurant is 0.25. What's the probability that exactly 4 of them will succeed? And again, we're going to start by identifying our 4 variables here. I'm opening 10 new restaurants, so that's my experiment. N is equal to 10. The probability of success for any new restaurant is 0.25. P plus Q have to add up to 1, so Q is 0.75. What's the probability that exactly 4 of them succeed? That makes R equal to 4. And now again, we run the substitutions into the formula. So we're going to start with 10 restaurants, and we're looking for exactly, in this case, 4 succeeding. We're going to multiply by P is 0.25. We're going to raise that to, and you look at the formula here, you're going to raise that to the R power, so that's the smaller number. You're raising that to the 4th power. And then we're going to multiply by Q, which is 0.75. And we're raising that to the, just look here, 10 minus 4 will be N minus R. We're raising that to the 6th power. You'll run that number through your calculator, and that will give you your probability answer. And I'll leave you to do the number button pushing on your own. Okay, moving on. We don't always ask about exactly 3 successes or exactly 4 successes or exactly 2 successes. We can also ask, what about at most 3 of the boys? Or what about at least 4 of the boys? Well, that's a totally different question. The family contains 5 children. Let's take a look at this little chart here. The family contains 5 children. That means 0 of them could be boys. It means 1 of them could be boys. Maybe 2 of them are boys. Maybe 3 of them are boys. Maybe 4 of them are boys, or perhaps all 5 of them are boys. So you could get busy using that formula and calculating these individual numbers. And when I ask you at most 3, well, what satisfies that requirement? At most 3 means I could have 0, I could have 1, I could have 2, or I could have 3. The most I'll have is 3, but I could have all those other numbers. So really what we'd need to be doing is calculating all those yellow dots and adding them all up. Lucky for us, we don't have to do all that number crunching. Let's identify the N. Well, the N is still the family of 5 children. The probability of success, still the probability of a boy, is 1/2. And 1/2 plus 1/2 equals 1. P and Q add up to 1. And we say at most 3. Now R is not just one number. R now becomes a range of things. Take a look at these blue numbers here. R now starts at 0 and goes all the way up to 3. So we actually have a range of numbers, 0 to 3. If I'm asking the at least question down here, well, it's the same setup. I still have 5 children. Probability of a boy is still 1/2. That means Q is still 1/2. I'm using all of those first 3 numbers up top. But when I get down to this R, now that's changing. This says at least 4 of them. Well, at least 4 of them means that you could have 4 of them or you could have 5 of them. And we could get busy calculating those individual yellow dots and then adding them up, but we don't have to. We have an alternative way of doing this out of our calculator. The important question here is, what is R? Well, if you look at those 2 blue numbers, this tells you now that R starts at 4 and goes to 5. So with that, I said we could get busy calculating individually all those numbers, and that would take us a while. We could use that formula that we just saw on the other page, but instead we'll go to our Inspire. Whenever you have an at most or an at least, you can use the Inspire to calculate them, and I'll show you how to do that. Now, there's one screen that you can use. When you have an at least or an at most question, you're allowed to use the Inspire to come up with the answer. You don't have to show the individual calculations. When you're asked about exactly, then you're going to have to come up with the individual calculations. You're going to have to show the formula substitutions, but you can use the same screen to check your answers and make sure that you came up with the proper answer at the end of the problem.